Matt Mitro is a cold water fisheries research scientist with Wisconsin DNR. I believe Matt actually might hold the record for the most presentations at these symposiums over the time that we've been hosting it. Matt's been a repeat solid presenter on fisheries science in Wisconsin. We really appreciate him. Today he's going to be presenting on survival of stocked and domestic trout in driftless area streams.
Thanks. So today I'm going to present some work on brook trout post-stocking survival study, two studies actually, on two driftless streams in Wisconsin. Now, trout stocking has been a cornerstone of fisheries management in Wisconsin and elsewhere in the driftless area for a long time. It's a part of our management program that's well supported by the public. Now, in producing hatchery-reared trout, we typically rely on producing these trout from a hatchery broodstock that reside in a hatchery or have resided in a hatchery over many generations. That's what we typically refer to as domestic stocked brook trout. Now, we have long recognized that these domestic brook trout that we stock don't perform nearly as well as wild trout. And we've kind of made a number of efforts over the years to produce hatchery-raised trout that are more closely related to wild fish in the attempts of making them a better fish to stock. And that's where the F1 and F2 trout come in. So I'm going to start with some definitions of F1, F2, and domestic brook trout. So in this figure here, starting up in the upper left, those two trout with the W next to them, those are considered wild trout. So if we go to a stream and collect wild trout, spawn them, take those fertilized eggs, and then incubate and raise them in a hatchery, those are what we now call F1 or first filial generation brook trout. So these are trout that are one generation removed from the wild. If we retain some of those F1 fish in the hatchery, raise them to maturity, spawn them, then we would create F2 or second filial generation brook trout. And as you do this over and over, you become further and further removed from the wild. And this is where we come to what we call domestic brook trout. So these are trout that have resided over many generations in the hatchery. Now, there's been work dating back in Wisconsin to the 1960s, kind of comparing these domestic brook trout to fish that are kind of closely related to wild fish. And one of the early studies that I found was done by John Mason, Oscar Brennelson, and Paul DeGers out of the Wisconsin Conservation Department. And, you know, again, at the time, recognizing that what we were producing hatcheries were not performing as well as we wanted in the field, they did a study comparing our domestic brook trout to what they referred to as wild streams of trout. These are essentially F1 or first filial generation trout, but they didn't call it that. And what they did was they took mature fish from Lawrence Creek, spawned them and incubated those fish, raised them in a hatchery for 9 to 10 months, and then stocked them out all in the fall. And they did that into 5 different streams around Wisconsin, comparing those domestic brook trout to the wild. And they also included some hybrids where they crossed the domestic brook trout with wild brook trout from Lawrence Creek. And I just want to highlight a couple data points from a table in their publication. Looking at the bottom, I highlighted in yellow the average percent survival of the wild Lawrence Creek trout, that WL column, and the domestic brook trout, the D column. And survival rate was significantly greater for those wild fish, about 15 times greater compared to the domestic brook trout. So although we knew going back to the 1960s that we could produce a better trout for stocking, that was more closely related to wild fish, we didn't really implement those changes in our hatchery program for a few more decades. And I suspect that probably had a lot to do with the kind of cost and feasibility of doing this, as creating hatchery trout that are more closely related to the wild is not a trivial thing to do. It's a very labor-intensive process. So this started in 1995 as part of our stocking program. We're stocking what we call wild trout. And Dave Petrano implemented some of this in our driftless area at that time with brown trout, and we also did it with brook trout. And this continued for about a decade or so until we started running up with production constraints, particularly in brook trout, where we were getting it from Ash Creek, where our ability to meet the demand for stocking these fish, we really couldn't meet it. So what our hatchery program did was started to retain some of these F1 fish in the hatchery, raise them to maturity, and create F2 fish. And we were essentially stocking both F1 and F2 trout as equivalents as what we called wild trout stocking, as compared to our domestic brook trout stocking program. Now, there had been some work done in the literature for steelhead trout, for brown trout, for Atlantic salmon, but not yet for brook trout, suggesting that as you got further away from the wild in terms of how many generations fish were being raised in the hatchery, there was a significant loss in fitness. So going from wild to F1 to F2 to F3, these studies are finding in some cases up to a 40% decline in fitness, or the ability of these stocked fish to survive and reproduce and pass on their genetics to their offspring. So this kind of prompted the first study that I did back in 2011, simply comparing the post-stocking survival of F1 and F2 brook trout to answer the question, could we or could we not consider these two different types of trout as equivalents? So just start with a map showing the two study sites that we use. The first one I'll talk about is Tenny Spring Creek. That's a small tributary to Elk Creek in Vernon County. And then the follow-up study I'll talk about is on Strutt Creek, also in the Driftless area, but down in Iowa County, Wisconsin. So for Tenny Spring Creek, again, a small stream tributary to Elk Creek. It did have a robust population of brown trout present, a wild brown trout, and there was a small remnant population of brook trout. So over the course of this study, we removed as many, prior to stocking, removed as many of the brown trout as we could. And then as we encountered them during the course of the study, removed them as well, and just transferred them downstream into Elk Creek. Beginning in 2011, and for 3 consecutive years, we stocked 500 F1 and 500 F2 brook trout into Tenny Spring Creek. So I'm going to walk you through what we found on this figure. I'll start on the left, just kind of describing the data and the models that we use for estimating survival, and then show you the results. So for Tenny Spring Creek, we looked at 2 different groups of fish that we stocked, the F1 and F2 brook trout. We had 13 different capture history occasions over the course of the study. That included 3 stocking events and 10 electrofishing survey events in Tenny Spring Creek. The sample size, over 3,500 trout encounters. That included the 3,000 that were stocked. We looked at a number of different types of models for estimating apparent survival, which is the probability that fish survived and remained in the population. But the models that were best supported by the data were 8 structured models. So I'm only going to show those 2 models best supported by the data here. So we did separate out the first year post-stocking from survival for fish that survived from 2 to 4 years of age post-stocking. Capture probability was allowed to vary over time. And then for survival, we modeled, look at 2 different age structure models. So for those fish that the first year post-stocking, we allowed survival to vary by time of stocking and the different among the different groups that were stocked. And then for those fish that survived the first year post-stocking, for the 2nd to 4th year survival is modeled to be constant among groups and across time. And we determined which model is best supported by the data based on the AIC weights. And that model was best supported by the data. There was also some support for a model in which we allowed survival to vary by group for those 2 to 4 years, or 2 to 4 years post-stocking. And so on the figure on the upper right, what I'm showing are the modeled average estimates of apparent survival for F1 and F2 brook trout stocked in Tenny Spring Creek. And what we saw was that beginning with the 2011 cohort, there was a significantly greater survival of those F1 fish versus the F2. And that difference persisted in the subsequent cohorts, although the overall survival did decrease from 1 year to the next as we built up the population of brook trout in the stream. But for those fish that survived past their first year post-stocking, thereafter, there was no significant difference in survival. So if those F1 or F2 fish survived their first year, thereafter, they had an equal probability of survival. We also noticed that after we stopped stocking fish in 2013, those F1 and F2 fish began to age out of the population, but we did start to see more wild fish being produced in the stream. So this suggested that perhaps those F1 or F2 fish were spawning and contributing to the population there. We didn't necessarily prove that because there were some remnant brook trout present in the population. And this study was not set up to do genetic parentage analysis for looking at that next step of whether these stock fish were reproducing and contributing to the population. But conclusions from the Tenny Spring Creek study, the survival of F1s was significantly greater than F2s for the first year post-stocking, suggesting that we probably should not consider them as equivalents. There's no survival difference 2 to 4 years post-stocking. diminishing returns in successive stockings as you build up the population in the stream, no difference in the growth of survivors, and there was likely reproduction by the stocked F1 and F2 trout, but we didn't quite prove that in this study. So that kind of led to the next study. So in 2018, we had the opportunity to kind of pick up where we left off and take it one step further to look at reproductive success or fitness of these fish that were being stocked. And we also included a third group in the mix, domestic brook trout. So today I'm just going to talk about the survival component of this study. The reproductive success component is ongoing, and we're doing that in collaboration with UW Stevens Point. Dr. Jared Homla is the geneticist in the Wisconsin Cooperative Fishery Research Unit, and he and his graduate student Andrew Tometz are working on the reproductive success component of this study. And I'm hoping that that work will be completed over the next year or so, and that perhaps they'll be able to present that at an upcoming Driftless Area symposium. So here I'm going to focus on the survival aspects of this study. So again, 2018, and for 3 consecutive years, we stocked F1, F2, and domestic brook trout into Strutt Creek in Iowa County. Strutt Creek was a little bit different in that there was a small population of brown trout in the stream, but there were no brook trout present. So, and again, all brown trout were removed during the course of the study and moved downstream. There happened to be a barrier in that stream that would prevent them from coming back. We used differential fin clips on the fish that were stocked, and we saved those fin clips for genetic analysis. And then for any fish that we re-encountered in our electrofishing surveys, we used visible implant tags, these color tags you see on this fish's fin, to keep track of capture histories for estimating survival. So now I'm going to walk you through another slide showing the Strutt Creek results. This is very similar to the one I showed you for Tenny Spring Creek. Again, this time we had 3 groups instead of 2, F1, F2, and domestic brook trout. We had 12 capture occasions, including 3 stocking events and 9 electrofishing surveys over the course of the study from 2018 to 2022. Our sample size of trout encounters was 5,888. That included 4,500 that were stocked over the 3 years. We again looked at, here I'm again showing the age-structured survival models. These were again the best supported models by the data that we had, and in fact, remarkably so, compared to what we saw in Tenny Spring Creek. Again, similar AIC weight value supporting as the best model, describing survival for these fish as being survival that varies based for the first year post-stocking, varying among groups and by time, and then no significant difference, or rather a constant survival rate for those fish surviving past the first year post-stocking. But looking at the figure on the upper right, what we saw was a little bit different than what we saw in Tenny Spring Creek. So for the first year stocking 2018, the 2018 cohort, we did see a significantly greater survival of the F1 fish versus the F2, and both of them significantly greater than the domestic brook trout. But thereafter, for the 2019 cohort and the 2020 cohort, we did not see that difference between F1 and F2 trout. There was no significant difference in their survival rates, but both of them were significantly greater in terms of survival than domestic brook trout. And then for fish that survive past the first year post-stocking, the figure does make it look like there's a little bit of variability between the groups, but according to the models, there was no significant difference in apparent survival for those fish. So this was a little puzzling. We were seeing for a couple of years that we did stocking in Strutt Creek, no difference between the F1s and F2s like we had seen in Tenny Spring Creek, and contrary to what we've seen in the literature. So let me first just summarize those conclusions from Strutt Creek. First year post-stocking apparent survivals differed among groups. F1s were surviving about 3.5 times, at a 3.5 time greater rate than F2s. F1s and F2s surviving much better than a domestic trout, 35 times greater for the F1s, 10 times greater for the F2s. But in 2019 and 2020, those cohorts, no difference between F1 and F2, both surviving better than the domestic trout. Again, 2 to 4 years post-stocking, no apparent difference in survival. We did get proof of natural reproduction in the stream. Again, there were no brook trout present prior to stocking, but by 2020, we were seeing natural production in the stream. As to what's happening between the difference between F1 and F2 in the Tenny Spring Creek study and the Strutt Creek study, my hypothesis as to what's happening is this. And here I'm showing, I think it's related to a change that occurred in the hatchery production of F2 trout. So in the work we did in Tenny Spring Creek, we had used a single source, single stream from which we derived brook trout for stocking. So I'll call this stream A. So we have those wild fish that was from stream A. This happened to be Ash Creek. And those fish, some of those were retained, F1s were retained in the hatchery, raised to maturity, spawned, and then created F2s. So all the fish stocked in the Tenny Spring Creek were derived from a single source population, Ash Creek. What changed in 2015, we had run into production constraints from Ash Creek and then questions about the genetics of the Ash Creek fish. So we switched to a strategy in which we were now using multiple streams of sources and rotating among those streams from year to year. So we're not pulling reproductive output out of the same stream year after year. And so here I'm calling streams B and C. So we begin by getting wild fish from stream B in 1 year, creating F1 fish from that stream and retaining some in the hatchery. Then the next year we go out to stream C, collect wild fish, create F1 fish in the hatchery, retain some of them for spawning. But then when we create the F2 fish in the hatchery, it's no longer being derived from a single source population, but we're crossing fish from multiple populations from, in this case, streams B and stream C. So these F2 fish are a bit different compared to the ones stocked in Tenny Spring Creek. And what I suspect might be happening is that, typically when you take fish from one stream, like the single source used in Tenny Spring, as you go from wild to F1 to F2, there's typically going to be a loss of genetic diversity. What might be happening when we're using multiple sources is that you do initially get that loss in diversity going from wild to F1, but then by crossing F1s, we might be increasing diversity back again. So I'm anticipating that the genetics work being done at Stevens Point will hopefully provide an answer to this question or this hypothesis as to if this might be the issue that is resulting in F2s coming from multiple source populations as performing better than the F2s that had been used previously for our wild trout stocking program. So I'll finish up just by recounting management recommendations I made from these studies. So for the Tenny Spring Creek study, the one that was done first, the recommendations that I made from that were keeping the F1 brook trout separate for priority stocking. So the F1s were performing much better than F2s. I thought it made sense to not consider them as equivalents, F1s and F2s. Keep those F1s for stocking in streams where we are perhaps reestablishing a brook trout population. We're trying to reintegrate native genetics into a population that was derived from domestic brood stock. And then the F2 brook trout are certainly much easier and cost-effective to produce, and they were probably suitable for stocking in hook, grow, and take streams, where we want these fish to survive from year to year to provide a fishery. But the one recommendation I made is that we probably should adjust the stocking quotas to list the same desired outcome. So if you're stocking X amount of H0 F1 fish into a stream with the expectation of having a Y number of them to survive to H2, you probably would need to stock about 3 times as many F2s to get that same response. And the management recommendations coming out of the more recent study based on Strutt Creek are now quite a bit different. So I think we can likely stock similar amounts of H0 F1s or F2s to have a similar amount of fish surviving to H2. Both F1 and F2 brook trout are far more preferable to domestic brook trout for hook, grow, and take streams. So I would not recommend putting domestic brook trout in those type of streams at all. But I do think more thought's going to be needed on whether a single source F1s or multiple source F2s are preferable for reestablishing wild populations or reintegrating native genetics. So again, that's a genetics type question, and I'm hopeful that the work being done by Jared and Andy at Stevens Point will kind of help us understand that issue. So with that, I'll leave up this slide, just kind of acknowledging the many people over the years who have participated in these 2 projects. And if there's time, I'll be happy to answer any questions.
We do have a minute for questions, and we had a couple come in. How do you identify the different cohorts of stocked fish?
We identify the different cohorts of stocked fish. We use a differential fin clip when we stock them. So the hatchery crew has been very helpful, and when we stock F1s or F2s or domestics, we give a small fin clip on a different fin to identify those different batches. Those fins do tend to regenerate over time as the fish grow. So we do quickly get into the stream a number of times following stocking. And as we encounter these fish again we then give them a differential tag. So we're putting a different color tag and a different fin to keep track of which group these fish come from.
Okay, and we had another question asking about the source of the B and C trout.
Yep, so we're originally using Ash Creek for brook trout for stocking in the driftless area. We've since moved on to a number of different streams. There's a whole host of them. I don't know to which extent we're still using each particular one, but it's been, I think, Langton Stream, Lowry, Katy Creek, and South Fork of Hay River. Might be missing another one in there, but so we're rotating among at least 3 or 4 different streams at the moment.